So, like functional requirements, all security requirements are not created equal. So in an agile method, what we would say is let's make sure we get the most important things first. What are our biggest concerns? And by the way, balancing the vulnerability, the potential vulnerability with the potential threat. Because if you have a vulnerability with no threat, that's probably not going to be prioritized really high. This is just a snippet out of a document, and I just wanted to put it up here for you because I'm going to talk about this document in a little bit. But the National Institute of Standards and Technology, which some of you may know is NIST, publishes a series of documents on computer security. And I actually participated in the writing of some of these documents. Crazy, right? I'm an agile participating in some of these. But what he said here, and this was about 4 or 5 years ago, and I thought this was awesome, was that security people need to be part of the team. This is in a NIST document. This is in NIST 853. And I'm going to talk about that in a second. So we want to make security professionals, not these police, not these, hey, coming in, throwing documents on the table and walking out, but really part of the team to build secure systems. I also include in here these vulnerability testers. Do you guys have penetration vulnerability testers in your organizations? Couple, okay, perfect. Okay, so let's talk about some of the, let me look at my time here. Let's talk about some of the roles and responsibilities of the different folks on the Scrum team and how they all contribute to building that secure product. So I'm going to go with the easy one first, right? The security engineer or the security professional. How many of you guys have actual security engineers in your organization? That's awesome. So maybe 5 years or so ago, that was probably unheard of. Right? I think security engineering over the last 5 or 6 years has really gained momentum as a discipline. So security engineering as a discipline has this really delicate balancing act of, yeah, we have to get this functionality out the door, but we also have to have sufficient security controls built in to mitigate the risk, right? To reduce the risk to an acceptable level. So they're kind of in this position of trying to be both, right? Trying to be a good teammate and get that functionality out the door. So, security engineers have in their arsenal a few things that they can do to help bring security requirements up front, right? When we're talking, as we talk through an agile development lifecycle, you know, some of these things are obvious, right? User stories. We use this all the time. Some of you may not have heard of this thing called abuser stories. I'm going to talk about that in a second. But some of these other things that we do every day, definition of done and acceptance criteria, are all things we can use to bring security forward in the process. So again, I mentioned this document. This is the NIST publication for computer security. This is NIST Special Publication 853. It's out on the internet. You can Google it. It'll come right up. How many of you guys have seen this document before? It's an incredibly thick document. But really, the most important part of this is Appendix F, which is the Security Controls Catalog. And just to give you an idea of what a security control looks like in this document, this is an example of one of the security controls, and I picked kind of the easiest one, a log-on security control. And what it relies on is classifying, or I don't want to use the term classifying because that means something different, but really looking at the data in the information system and assessing the impact of confidentiality, integrity, and availability. So if any of those things are compromised, what would be the impact to the data? So really focusing on the data for the system. And based on that assessment of how the data would be impacted, if one of those things was compromised, then you would either select or not select some of these controls. These become really just pure security requirements. These are things that could get put right into your product backlog. In fact, in this particular example, there is a control, this one's AC9, about log-on notifications. So this is about logging, log-on attempts, log-on attempts. And then there's certain enhancements. And each of those enhancements is in and of itself its own security requirement. So these are things that would be selected individually for your particular project and prioritized right into your backlog, right along with all your functional stories. So let's talk about the definition of done. This is another way we can bring our security forward, right? So every Scrum team has a definition of done. Definition of done is, for those of you who don't know, I'm assuming everybody knows, the definition of done is what does it mean for a story to be completed? Right? So typically it's things like code is checked in, unit test pass, product owner accepts it as done. There's a couple of other examples here. But how can we use definition of done to remind us of our security responsibilities? So let's say this is our definition of done for our team. What can we add in here from a security perspective just to keep us reminded of our responsibilities? I'm sorry? Yeah, so having them kind of give the thumbs up. What else?
So would you expect the security to be part of your acceptance tests? So all security tests pass?
All security tests pass, good. I know in the federal government, for example, we have documentation that's required. Right? We have system security plans. So perhaps if there was a security relevant feature, right, that system security plan needs to be updated. So that might be something we would add to our definition of done, making sure that the system security plan is updated. Any others?
Just have someone actually try to break it. Actually, just develop a resource to, actually run and several attempts in order to break it in ways that they haven't played with before.
Perfect segue. I'm going to pay you later for my next topic, which is this concept of abuser stories. So thank you. So abuser stories. How many of you guys have heard of this concept of abuser stories before? Nobody, except Brandon, because he's heard it before. So abuser stories are basically a user story that is written from an attacker's perspective. So basically what you were just saying, which is, how can I break this thing, right? And it really requires us to put our, bad guy hat on and look at our system, objectively from an adversarial perspective. So here's a couple of examples of what I'm talking about in terms of what an abuser story is. Who would write these? Who could write these from your team? Security engineer? Who else could write them?
Everybody.
Yeah, everybody can write them. But it really requires everybody to start thinking like the bad guy. Right? Even seemingly innocuous functional stories can create small vulnerabilities in your system. These things get written just like user stories. They get added to your product backlog along with all of your other functional stories, security requirements. These are kind of hard to start writing too, because it really does require you to think the other way, to flip things around and start thinking, how can I break into my own system? Okay, we're going to talk a little bit more about abuser stories later with regard to some of the other roles. So just kind of to sum it up, the security engineer, the security professional really can contribute to the team in a bunch of different ways, right? The definition of done, making sure that everything that's on the definition of done really does address any security concerns. helping prioritize requirements in the product backlog, not only security requirements, but looking at those functional user stories as well, and making sure that they don't have any security relevant criteria. One of the really good things that a security engineer can do for a team is helping the development team understand why the security requirement is important. Developers are not security professionals, right? And so understanding what the business value is around that requirement is really critical to helping the developer actually implement that security requirement. None of our security engineers look like that, but the point here is that they really should be talking. Do you have security engineers that look like that? Or developers? Who wears the tie bar, really? It's funny, because I think Brandon's my colleague up here in the front. He actually, I had another picture like this. It was the Scrum Master, and he kept saying, no, Scrum Master looks like that, and I think this one's the same one. I kept threatening to put a picture of my husband there instead. But anyway, the point here is that these people have to talk. This should not be an adversarial relationship. This person really should be part of the team. Yesterday, I actually found an article that I found really interesting. I did some work years ago with NSA on their security engineering program. And they were really struggling with finding true security engineers. Okay, because this is what a security engineer is. It's all of these things. Right? So a security engineer really has to come to the table with all of this wealth of information. And oh yeah, at the bottom of it all, they have to be a good team builder, right? Which is a different mindset that we usually have from security professionals, right? This is a person who really has to be collaborative with the team. But anyway, NSA had been struggling for a long time to find people, shockingly, with all of this information, right? And so what we learned during the course of kind of filling these gaps was these security engineers really are systems engineers at heart. The fundamentals of security engineering is pure systems engineering. And then layering on top of that, the information assurance principles. Those are the folks that really make the best security engineers. And they can delve deeper into some of these areas as specialties, right? So whether they're specialties in protocols or networking, right? So they can have these concentrations of specialties. But interestingly, what the article I saw yesterday, and I was going to bring it up, but it's too hard, so I'll just describe it, is that they were talking about these centers of academic excellence now that NSA is going out and branding basically